Prepare to be amazed, for astronomers have made a groundbreaking discovery. The hidden secrets that lie deep within the core of Mars have been unveiled. Surprisingly, the red planet is not as devoid of life as we previously believed. Once upon a time, Mars was a vibrant and flourishing planet. Throughout its history, the planet exhibited a plethora of compelling evidence indicating a warm climate, the presence of liquid water lakes, and a brief period of habitability. For years, astronomers have been driven by an insatiable curiosity to uncover the truth behind this enigmatic shift. Their relentless pursuit of knowledge has led them to delve deep into the heart of Mars, seeking answers that lie hidden within. As the InSight lander delved into the depths of the planet, it made a remarkable revelation. The planet's interior is alive with seismic activity, constantly rumbling and shaking. After an arduous 5-year endeavor, InSight has provided scientists with a remarkable glimpse into the heart of Mars. I'm curious about the differences between the cores of Mars and Earth. Can you shed some light on this? How did InSight go about revealing the inner workings of the red planet? Ultimately, the question that lingers in our minds is what this signifies for the future of our planet. To truly grasp the significance of InSight's mission on Mars, it is crucial to delve into the fascinating story of how scientists unraveled the enigma of Earth's core over 100 years ago. Everything is just a dance of waves. Scientists often study seismic waves, which are shock waves that travel through the Earth's interior in order to understand its internal structure. These waves could come from natural events like earthquakes or from human activities like controlled explosions. Through careful examination of the behavior of these waves as they travel through various substances, seismologists are able to deduce the characteristics of the materials they encounter. Similar to how light waves interact with objects, seismic waves also change their behavior when they encounter different materials. These changes can include transmission, reflection, absorption, refraction, polarization, diffraction, or scattering, depending on the composition of the object and the wavelength of the seismic waves. There are two main types of seismic waves: P waves and S waves. P waves, also known as primary waves, induce vibrations in rocks that align with the direction of wave propagation. As the earthquake's epicenter rumbles, these seismic waves race ahead, arriving before any others. S waves, also known as secondary waves, induce vibrations in rocks that are perpendicular to the direction in which the waves travel. They move at a speed that is about 60% of the speed of P waves, reaching their destination after the P wave has already moved through. Back in 1906, a fascinating discovery was made by seismologists. They stumbled upon the fact that seismic waves traveled at a noticeably slower pace when passing through the Earth's core compared to other parts of our planet. What's even more fascinating is that they noticed how S waves couldn't make their way into the core, while P waves managed to travel through it, only to be redirected at the core's boundary. Based on these observations, it was concluded that the outer core is in a liquid state, while the mantle above it remains solid. Additional research has deepened our comprehension of the Earth's core. In 1936, researchers made an intriguing observation. They discovered that seismic waves, when they encountered the inner core, exhibited peculiar behavior. Instead of passing through, the waves bounced back. This unexpected phenomenon hinted at a remarkable transformation occurring within the Earth's core, a transition from a liquid to a solid state. Through meticulous seismic studies, a series of groundbreaking discoveries have shed light on the intricate layers of our planet's core. Now, let's jump ahead almost a century and delve into the depths of Mars, where scientists have used seismic techniques to uncover remarkable findings. In 2018, the Mars lander InSight was sent on a mission to thoroughly study the crust, mantle, and core of Mars. Its name, InSight, stands for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport. One crucial aspect of the mission involved placing a seismometer, called the Seismic Experiment for Interior Structure, on the surface of Mars. This device was created with the purpose of capturing seismic activity and producing accurate three-dimensional representations of the Earth's inner workings. Throughout its 4-year mission, InSight was able to detect a multitude of marsquakes. But it was in 2021 that the story took a fascinating turn. During this year, InSight captured and recorded two noteworthy occurrences on the far side of the planet. There was an event that caught everyone's attention, a massive marsquake that surpassed all previous records in size and power. Another noteworthy incident was a meteorite impact that caused quite a stir on the planet. These events, happening on the opposite side of Mars from InSight, offered a one-of-a-kind chance. Now, the lander had the remarkable ability to analyze waves that not only journeyed around Mars, but also passed through it. This breakthrough provided researchers with an unparalleled glimpse into the seismic waves that traverse the Martian core. The plot thickened as scientists compared the travel times of these seismic waves through the core with those remaining within the Martian mantle. Through the integration of these data with other seismic and geophysical measurements, an estimation of the density and compressibility of the materials the waves traversed was made. Surprisingly, the results were not what anyone had anticipated. The core of Mars appears to be a soft, fluid substance throughout, in stark contrast to Earth's core, which is believed to have a liquid outer core and a solid inner core, potentially housing an even denser core at its center. In addition, researchers discovered that the core of Mars contained a significant amount of lighter elements scattered throughout. Typically, these components make up almost 20% of the Earth's total mass. Sulfur takes the lead as the most abundant, with oxygen, carbon, and hydrogen following in smaller quantities. The composition of Mars' geological makeup is truly remarkable, highlighting its distinctiveness. Based on these findings, it appears that the core of Mars has a lower density and is more compressible compared to Earth. The magnetic field on Earth is sustained by the geodynamo activity occurring within the core. Let me tell you a story. Once upon a time, deep within the Earth, there was a journey of heat. It started from the fiery heart of the planet and made its way towards the outer core. As it traveled, it stirred up currents in the fluid that flowed through the mantle. As the planet spins, these currents can coil into intricate patterns, giving rise to a magnetic field. As the fluid moves, it creates a magnetic field. This magnetic field then interacts with the fluid motion to generate another magnetic field, which is called the dynamo effect. The self-sustaining magnetic field of Earth is rooted in this mechanism. In previous studies, researchers explored the possibility that the inclusion of lighter elements in the Martian core could have played a significant role in the decline of its dynamo and subsequent loss of its magnetic field. With a deeper grasp of the composition of the Martian core, we now possess the tools to reconstruct Mars's history with greater precision. The core of a planet holds valuable clues about its origin and how it has changed over time. Let's consider an example. The remarkable structure of Earth's core allows it to create a magnetic field that protects us from solar winds. This shield is crucial in safeguarding our planet's water and supporting the growth of life. On the other hand, the core of Mars does not generate this protective shield, making it unsuitable for any known life forms. Through these investigations, we gain valuable insights into the identification of alien worlds that could potentially support life. Additionally, we deepen our comprehension of the various processes involved in the formation, growth, and evolution of planets over time, even when they arise from similar materials in close proximity to a star. Even though the InSight mission came to an end in December 2022, the valuable data it collected during its 4-year journey on Mars will have a lasting impact on our knowledge of how planets form and evolve. This is a remarkable testament to the timeless significance of scientific exploration and discovery. In a stunning revelation, astronomers have made a groundbreaking discovery: the deterioration of the Earth's magnetic field has taken a turn for the worse. Malicious actors have found a way to take advantage of social media platforms, targeting and exploiting vulnerable users, such as children, adolescents, and individuals with mental health issues. Through the use of social media, predators have found a platform to groom and manipulate unsuspecting victims. Additionally, individuals who are already grappling with mental health challenges may find themselves exposed to harmful content or communities that only worsen their conditions.